gracious in bringing me here. But above all, I want to say that this paper is really a joint effort with Stefan Sinclair. Anything brilliant is his, anything pedantic and slow and ponderous is mine. À la fin des années 60, Joseph Weizenbaum a développé un interlocuteur automatique qu'il a baptisé Eliza et qui a connu un franc succès à l'instar de la marchande des fleurs d'un Pygmalion de George Bernard Shaw qui lui a prêté son nom. Alors que certains voyaient en Eliza un exemple du potentiel de l'intelligence artificielle, Weizenbaum lui-même n'était pas dupé de sa création et du même répéter son manque d'apprentissage. Il n'empêche que nous pouvons nous plaire à parler à Eliza et à d'autres interlocuteurs de son genre. Eliza, malgré ses défauts et sa simplicité, continue à nous divertir, à nous construire en dialogue. Et peut-être le seul vrai moyen de l'appropriser est ce de noyau de cette interaction, comprendre en dialoguant de l'interprétation informatisée. So by now you're aware of the fact that my French pronunciation is good. Weizenbaum started his 1966 paper on Eliza by stating that to explain is to explain away, by which he meant that explaining Eliza's processes in the paper would unmask her in such a way that lays bare the procedural beneath her magic. We all know how, for example, explaining a joke can spoil its magic. Likewise, to explain text processing procedures can spoil their authority. And of course, that's what I'm going to try to do today. In this paper, we want to see if we can resurrect Eliza's magic in dialogue. We want to see if we can recapture the beauty of a simple algorithm for text generation by replicating it, and replicating it in different ways. Weizenbaum, with good reason, was afraid the surprising effectiveness of the algorithm would mislead users like as if it were an AI in a Turing test. We now know the Eliza algorithm rarely satisfies for very long. There's little danger that she will learn enough to fool us. Instead, it is in the figuring her out, fooling her and replicating her that the learning comes, learning that is ours and not Eliza's. Suivons donc le trajet qui se désigne devant nous en forme de spirale qui mène au cœur des textes et des outils, seuil de dialogue. Notamment, nous allons commencer par une démonstration de Eliza, implémentation de Eliza dans Voyant, qui permettent un dialogue entre le lecteur, le texte et la machine. De prendre un pas de recul pour se demander ce que nous cherchons lorsque nous dialoguons avec une machine. Nous ferons l'esquisse d'une série d'expériences qui cherchent à rassembler un texte et des rebelles herméneutiques en dialogue. Nous terminons par une démonstration de spirale, notre récente conception herméneutique qui conjugue algorithmes et arguments dans la forme des cahiers interactifs. Now I'm going to be doing a lot of demonstrating, and it's bound to blow up. I've got slides, but everybody's got to keep their demonstration fingers crossed for this. So I'm going to start by giving you a demonstration of Eliza. So this is your standard for those, and I apologize to those of you who know Voyant, but this is what it looks like if you go to the standard Voyant. We're actually using a beta version because the version of Eliza I'm showing you has features that the standard one doesn't have. When you're using Voyant, you first have to give it a text. In this case, I'm uploading a text, which is a version of Frankenstein from Gutenberg. And once you upload the text, it gives you, this is the standard display. For those of you who haven't used Voyant, Voyant has all sorts of tools within it. We have, for example, word cloud, the full text, trend maps, keyword in context, summaries, and there's lots of other tools that are hidden away there. And the tools are loosely connected. If you click on father, it'll now give you the trend of how the relative frequency of father, or actually the raw frequency of father over the text. So this is the sort of standard display. I'm happy to report that according to Compute Canada, this is now the most used tool on Compute Canada. Over 200,000. It's a very shallow column. So, you know, I think it's used a lot for teaching. But one of the things you can do in Voyant is you can go and call up other tools on the same text. So I'm now going to call up Eliza on the Frankenstein text that we have there. And if any of you have ever played with Eliza, you know it's a sort of dialogue environment. We've implemented it a little bit like a chatter bot here. So I can ask Eliza, you know, have you read Frankenstein? And it responds, what are your feelings now? But we've added some extra features to Eliza. One of them is I can actually pass language from the text itself to the therapist, if you will. So it will randomly grab a piece of text, and I realize it's hard to read here, but the text is from the Frankenstein novel. I carefully traced the windings of the land and hailed a steeple which I at length saw issuing from behind a small promontory. And Eliza says, can you elaborate on that? Another feature that we've added is that you can actually ask for, let's see, this works. I can ask for occurrences of father. And now, what Eliza is doing is it's actually going back to Voyant and calling up a keyword in context. Because I asked for occurrences, the script of Eliza has been programmed to read that, to understand it as a request for a concordance. And in effect, I've gotten a small embedded concordance inside the dialogue. And if that doesn't get sufficiently spiral enough or meta enough for you, you can always open the script editor and edit the script to your content. So this is the script that actually controls Eliza. It's essentially the same script that controls the standard Doctor implementation of Eliza with these extra features, and you can edit them live. I'm going to talk about the script later on and show it to you. So that's my short little tour through Eliza. I'm now going to return to the boring parts. Eliza is a version of Weizenbaum's original Eliza, described in the 1966 article entitled Eliza, a computer program for the study of natural language communication between man and machine. Notice his subtitle there. The original version was written in a list processing language called Mad Slip, developed by Weizenbaum and named perhaps as an echo of the popular Mad Libs game. And here you see an example that I just took off the net of Mad Libs. Perhaps you played it when you were children as a sort of party game. The Mad Libs game is one where one player prompts others for parts of speech like nouns and adjectives to fill in a passage. Then you read out the passage and you get something that's grammatically correct but ridiculous and therefore amusing. It is, if you will, an analog text generation game, bringing a simple algorithm together with canned text. As important as the Eliza algorithm is for the generating of text, it is the script that really guides Eliza's responsive parsing of what we write. In fact, most of us experience Eliza teamed up with the Doctor script that mimics a Rogerian psychotherapist. This script, a version of which was appended to the original 1966 Weizenbaum article as an appendix, works well because, as Weizenbaum himself writes, from the purely technical programming point of view then, the psychiatric interview form of an Eliza script has the advantage that it eliminates the need of strong, explicit information about the real world. The script works because the machine doesn't need to know anything about the world. It's just sort of playing tennis with you and bouncing your words back to you. A psychotherapist who just turns what you say back into questions for you to reflect on doesn't really need to understand the world so much as be elusively gnomic. Douglas Hofstadter later named this phenomenon of a computer program appearing more intelligent than it is the ELIZA effect. And this is an awkward title, Preface for, the Ineradicable ELIZA Effect and Its Dangers. Notice ineradicable, which appears in a collection of essays on artificial intelligence. He goes to great lengths to make clear that ELIZA and other candidate AIs that were being praised at that time in the literature had no idea about what they were talking about. They were not intelligent. ELIZA generates text, but not meaning. It does pattern matching and manipulation, but not understanding. It doesn't understand the words it uses. The words could be nonsense. It's just rearranging them. And it just takes the interlocutor's words and reassembles them following simple rules, much like the Mad Libs. There's no deep learning going on or complex code, just a very well-written script. If you will, we could say that there isn't really a dialogue, or the dialogue that is there, it's not that the machine is understanding the person responding so much as it's batting it back to them. What really annoyed Weizenbaum, and later Hofstadter, was first that people became to believe the computer had a complex understanding of the dialogue taking place because of the apparent inspiration of the answers. If it answers smart, it must be smart. That's the ELIZA effect. So that was the first thing that really annoyed them. Second, they were professionally worried, because both Hofstadter and Weizenbaum were working in the area of artificial intelligence. They were professionally worried that people would think ELIZA was a real advance in AI rather than a little NLP trick. The effectiveness of ELIZA apparently actually changed Weizenbaum's career. His toy was so successful, he had to spend the rest of his career explaining to people why it wasn't as good as they thought it was. And he became actually fairly one of the first fairly well-known critics of AI. By the way, I don't know if you all noted the recent passing of Hubert Dreyfus, who was really one of the most trenchant philosophical critics of AI. While we can sympathize with the computer scientists that worried that a cheap trick had gotten out of control, raising expectations that about the real science of AI couldn't live up to. From a humanistic, rhetorical perspective, the ELIZA effect is actually something that should interest us quite a lot. It's a cousin to the suspension of disbelief that artists take advantage of. And there's therefore something of interest to anyone who studies the expressive arts. The willingness of people to treat a media object as expressive of real human thought makes the art of the media work. The ELIZA effect could be compared to other artistic effects like montage in cinema, effects that we allow to fool us into following stories. I'm not the first one to say this. In fact, Noah Wardrop-Fruin deals very nicely with the ELIZA effect from a humanities perspective in his book, Expressive Processing. And he's actually building on Janet Murray's Hamlet and the Holodeck. And I actually saw Janet Murray when she came to be a keynote speaker in a conference in Toronto back in, I want to say, the 80s or 90s, before she had finished Hamlet on Holodeck. And I was in the room when she was being interviewed by CBC, and she was showing a toy that she had built to teach students to write scripts for ELIZA. I think it was built in HyperCard at the time. So she was not only noting that this was interesting, but seeing it as something that humanities students should learn to program these types of characters. More generally, Wardrop-Fruin's book is about how computers can be programmed to be expressive. The ELIZA effect is only one chapter. He looks at a number of different types of ways of making a computer expressive. And thus, he usefully bridges software studies and game studies. It's really an important book in some ways for our field. We think of our project, what Stefan and I are doing, as analogous. We're interested in the potential for hermeneutical effects from algorithms or in machines. Waterford also points out that the ELIZA effect usually breaks down pretty quickly, which is why it isn't really that effective at all, unless the interaction is very severely limited to either prevent people from talking more than a certain while, or they're talking very narrow sort of bandwidth. The more sustained entertainment lies in figuring out how the computer does what it does and getting it to say ridiculous things rather than in having a meaningful dialogue. ELIZA can be a great way to get students thinking about algorithms that manipulate language. It can also be set up as a creative environment where the user can edit the script as they play, creating a character. And that's in effect what we're doing with ELIZA. You can not only work with it, you can throw the text at it, you can then start editing the script and seeing if you can manipulate it and build your own characters. That's how we think of it in ELIZA, as another tool for thinking through interpretation, the one where you try to script a character capable of interpreting a text, an idea we draw actually from the Ivanhoe game. What it doesn't really do, what ELIZA doesn't really do, is interpret the text itself. You interpret the text while eavesdropping on your scripted character. So how does ELIZA work? What is the procedure that generates the dialogue? And here's where I sort of ruin the magic of ELIZA for you, if you haven't already had it ruined for you by explaining it. Here I'm showing you just part of the script. There's a bunch of other parts, but there's a section where you define how you want the thing to start out. What should it say when you start? You can also define what you want it to say when somebody stops and quits. But the heart of it is a series of rules about how to respond to keywords. And so what you see here is, how do we respond to the keyword remember? And the first thing is, how do you decompose a sentence that has the word remember in it? And the star would mean 0 and more words. So if it comes across a sentence with 0 more words and then I remember blah, 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 something or other, it then reassembles it to, do you often think of, where 2 is whatever was in the second position. And you can have a whole series of these rules. You can have many decomposition rules for one keyword, and then you can have many reassembly words for one decomposition rule, and then sort of randomly goes through these things. And as long as you don't dialogue with it too long, it feels fresh. And of course, being a Rogerian psychotherapist, the keywords are defined mostly as the sorts of things that would have to do with your mother and your father and family. And then there's a set of rules for when it doesn't recognize anything. And of course, the brilliance of the script writer is, if you write funny things, and if you write the right funny things, it sounds like a smart intervention, even though it's just a random thing pulled out of a list. So that's the ELIZA algorithm here. So if we think of ELIZA as a dialogue machine, we can witness the following types of interactions. There's the interaction that you have with the chatterbot. And in ELIZA, you actually have the further interaction that you can ask the text that you're studying, you can grab text from it to stand in for you. So in some sense, the text can become your character. Then there's the interaction between the algorithm and the script. And in the case of ELIZA, where you can edit the script live, there's that final sort of meta level where you are editing the script and then watching the dialogue that happens. And this business of watching dialogue is going to be important to me. So at this point, I want to switch and ask the question, what is dialogue such that it might be a way of interpretation? Dialogue in the Western tradition is associated with Plato and Socrates, specifically the Socratic dialogues. Dialogues like the Meno have provided us with an ideal of Socratic questioning where the educator elicits answers from the student through a careful sequence of questions. And we probably all at one point or another written a teaching statement about how my style of teaching is the Socratic dialogue where I ask questions and I draw knowledge out of people. This goes right back to the Meno. In this therapeutic model, the Socratic interlocutor helps you figure things out rather than telling you what to think. It's not a lecture, it helps you figure things out. The doctor script for Eliza can be seen as a psychotherapeutic analog to Socratic questioning. It doesn't tell you what you should be feeling, it keeps on reverting it back to you. It decomposes and reassembles your words in a way that might help you realize what you already know or should know. And there's all sorts of testimony about people who were deeply affected by the Eliza algorithm. But there's not all sorts, there's about 2 or 3 canonical stories that circulate, especially one about Weizenbaum's secretary, who should have known, the theory is she should have known better, and yet she got caught up in a sort of intimate dialogue with Eliza. Alas, that isn't really how dialogue works most of the time. Whether the dialogue represented in a text of Plato or the reality of our classroom dialogues. Dialogue is rarely for the education of the person questioning. It is the audience of the dialogue, everyone else who's listening in, whether the Socratic circle that Plato carefully takes pain to describe, listening in on the humiliation of the great man. Remember why Socrates was martyred? Because he didn't make those people feel any better. He got them really ticked off. He humiliated them in front of a circle of other people. And when you read the Platonic dialogues, you don't find nice Socratic questioning, except for in the Meno, you could say the Phaedrus, and a couple of other ones. And in fact, if you think about your own teaching, even if you are eliciting something from your student, you're doing it in a way that is meant to be witnessed, to be eavesdropped, listened in on by the rest of the students. Dialogue, like theater, doesn't have to actually mean much to the talkers. They can be thinking about something completely different. It's the eavesdroppers, it's the audience that matters. Therefore, we will hypothesize that what we should want in the dialogue of interpretation, especially that with computers, is to be the witness, not interlocutor to the conversation. We want to create an environment which gives us an interesting dialogue to read and reflect on. And reflection is key here. In other words, Eliza needn't learn a thing. What we want is for an unfolding conversation, even one meaningless to the computer, and we want one that's provocative of reflection, especially the sort that we call interpretation. We want to see interpretation reflected in a way that helps us, in turn, reflect on interpretation. Let's say that we want an occasion for dialogue, not to be questioned. So you can see now how Eliza might support such a dialogue in that it lets you interact with the text, Eliza's script, tools, and conversational flow. You can ask questions, you can ask for displays, you can push random parts of the text. Unfortunately, what Eliza doesn't do, or doesn't do that well, is it doesn't really leave a record. It's harder on the reflection. You have this sort of dialogue, but you can't really save it. And you can't really go back and edit it. And in fact, what you can't do is one of the most fundamental forms of reflection that we do in the humanities, which is with the reflection of writing, where you write your ideas out, and then in some sense you stand back and witness your ideas, reflect on them, and then edit them, and enter into this funny relationship of being an eavesdropper on your own thinking. And that is what we would like to be able to do with Voyant and with our tools, is to create an environment closer to a word processor, if you will, for the writing out and then reflecting back on your ideas, but one that brings the machine in. So at this point, I just want to step, what am I doing for time? I just want to, before I sort of show you our last implementation, I want to point out that Stefan and I have actually been struggling with ways of integrating text and tool for some time. I want to give you a little tour through some of the ways that we liked but didn't work, leading up to the current Voyant and Hermeneutica, and then I'm gonna risk my life by showing you something that's super beta. So one of the first experiments that we did was in the context of the text analysis portal for research. This was a CFI-funded project. It was funded in 2002. We built the portal over the next couple of years. It was an extremely ambitious attempt to create a portal that leveraged web services. You've probably all forgotten what web services were, but portals and web services were really hot in about 2001, 2002, which is why, of course, course. You grab what's hot and you say you're going to do it for the humanities, and that's how you get money. One of the things the portal did is it allowed people to get accounts and then create collections of texts. But you could also, in your accounts, you could define web services that you had built as tools for yourself and others. And then when you were looking at one of your texts, you could click a little button called Analyze Text, and it would put your text next to the tool, and you could draw on compatible tools or any of the tools that were in the system. And it would automatically generate the screen where you'd enter the parameters, and then you would hit it. The portal would go and grab your text. It would then go off to the web service, which could be on the other side of the world. It would process your text, come back, and send you the results. And we had a very cool environment where you could define these web services. So, you could define the endpoints. You could actually define in an XML language the form that you wanted people to fill out. Fabulous technology that didn't work. Why didn't it work? Number one, web services are too fragile. If you're Google, you can make them work. But if you're a humanist that has a server that runs 10% of the time, and you define that as a web service, and then over here in Canada, these crazy Canadians, set up this elaborate system, and then that web service is down, and someone's trying to use it. They have no idea what went wrong, and they never return to the portal again. So, and I say this because there are projects happening right now in Europe where they've gotten all excited about web services, and God bless them, I hope it works better. So then we decided to try to make something more robust, which was to write the HTML code, which would call the tools that we ran and knew we could run fairly robustly directly, and we just gave that out to people so that people could, if you had a database-driven content site where you were dealing up, in this case it was the globalization compendium, it was hundreds of papers and interventions of various sorts around globalization. Because that was being generated automatically, every page could have this toolbar. You could type in what pattern you wanted a concordance for, you hit the button, and poof, it would take whatever text you were looking at, send it to our tool, and return you results. And that was sort of worked, but not that many people used it. We had DHQ for a while, was using a version of it. DHQ, Digital Humanities Quarterly, was using a version of it, but it wasn't, to be honest, people were not using it a lot. We then tried to make it even more robust. We implemented a tool in Flash, and we came up with a rather silly name, Tattoo, for text analysis tube, for YouTube, so to speak. It was supposed to be the poor man's, or the everyday man's text analysis, but because it was done in Flash, it was just like one of the embedded video players, back in the 2005-10 sort of range. Because it was done in Flash, the computation happened on your machine, which actually made it more robust, and we could do nicer things with the visualization. Still sort of clunky. In the current wand, and this is what we talk about in the book Hermeneutica, and we actually have examples of it. We took a different approach. We started to go back to thinking about this business of the writing and figuring out, can we embed hermeneutical toys inside the rhetoric, the writing that you're doing? And so we set something up, and this is true right now of Voyant. Anytime you see a panel that you like, and a panel will be a combination of tool and particular text, you can go to the options and you can get the iframe code to put it into any other web page. And this has been used, for example, here you're seeing it in a conference web page where the word cloud is a live word cloud generated from a set of text, not necessarily the page you're looking at. It could be a different set of pages, the abstracts of the conference or something like that. And people have been embedding this in different places. And we took that idea, and for Hermeneutica, we proceeded to write a series of essays which combined our, if you will, our interpretation and the tool text panels inside. And if you go to the website Hermeneutica, so you just put the period before the CA, I have, as many of you already know, I have cornered the market on Canadian philosophical domain names. So Theoretica, Hermeneutica.
I hope Hermeneutica from you.
I had Hermeneutica, and I gave it to Michael. So you'll find 4 of the chapters of the book.
Philosophical.
I philosophical. Epistemologica. I have Ludica. But you can actually tell the maximum number of books that I and Stefan based on domain names. So if you go there, you can actually see the essays, the same essays that appear in the text in the book. You can see, and now instead of having dead graphics, they have live panels. And you can go in and play with the parameters and see if you actually agree with us, which is sort of moving along the lines of what's happening in the sciences, where when you present results in a paper, you also include the algorithms and the data so that people can try to replicate your results. To be honest, this was not still really the sort of interactive dialogue that we wanted. And we returned to this idea of writing. In this type of situation, we really were playing with Voyant and then going and writing an essay and then combining the two together. The actual thinking and interpretation was not happening in one environment. Because it's just, even though it's fairly easy in Voyant to get the code, you still have to go and you have to do it, you have to get the iframe, you have to then go drop it into your HTML and so on and so on. It wasn't something that was going to be convenient for the thinking and interpretation. It was something you could do after the fact to, in some sense, report it. What we wanted was the immediacy of doing reflection in a writing environment. Something a little bit like what we're beginning to get in ELIZA, that sort of dialogical immediacy where you can call up different panels and something like that. And we found ourselves, therefore, looking elsewhere, and we also have a separate problem, which is the problem that you always have if you build a tool that people use. You begin to get lots of emails in which they say, could you add this feature? And so rather than infinitely adding features, and if you've used Voyant recently, you've probably discovered that we are adding feature after feature, but rather than sort of overburdening it with features, we decided we wanted to look and see if we could also find a more extensible environment. And what we did is we settled on a programming paradigm called literate programming, or nowadays it's often called notebooks. What I'm going to do is I'm going to very quickly show you some. I'm going to show you some literate programming, so you've got an idea. This is not R. I mean, this is a literate. This is our notebook, but the environment is not ours. This is a standard environment that people are using for especially data analytics. So here's a notebook we wrote as part of a collection called The Art of Literary Programming, which we wrote actually for teaching purposes. But what's really nice about the notebook model is that you can combine the text in which you're thinking out the ideas with blocks of code. The blocks of code can be run, and then the blocks of code can actually generate results. Then you can iterate over it. If you don't like one set, you can continue this sort of keeping this transcript of code, text, reflection, and results. And it all gets sort of saved in one place. In this particular case, this is one of the first of a series of reflections that we call replications. This graphic here is from 1887. It's one of the first text visualizations. It was a guy, a really maverick genius called Mendenhall, who thought he could actually figure out a sort of visual signature for authors using word lengths and something like that. And so we set out to see if we could replicate his results. And what you see at the end is we're comparing what we got using all of our twists to what we got. So that's the idea of these notebooks. And if you're interested, if you just Google the phrase "the art of literary text analysis," you can see our collection of teaching sort of notebooks and some utility notebooks that were all done in IPython. And I recommend IPython to you. It's actually a great language to teach students for analytics, not for interactive. It's not for students who are going to do game design, but for data analysis, especially textual analysis, it's quite good. And it has the advantage that they can do things that they couldn't do in Voyant. It's a great sort of next step. Literate programming has an interesting history, which I want to spend a moment to reflect on. It was first described, and the word was coined by Donald Knuth, the sort of father of algorithms. So this is not a digital humanist. This is like the grandfather of computer science. In 1984, he described it as an alternative to structured programming. Literate programming emphasizes the primacy of thinking through in a literate or human-readable fashion what a program should do. As Knuth put it, instead of imagining that our main task is to instruct the computer what to do, let us concentrate rather on explaining to human beings what we want the computer to do. In other words, he's shifting the paradigm of what programming is from ordering the computer to writing something that's meant to be read by others so they understand what you're trying to do with the computer, which to me is hermeneutics. So then the challenge became, and this will be my last and most dangerous demo, the challenge became for us, could we actually improve on the programming, the literate programming environments that are out there? And there are actually quite a few. One of the best known and very expensive is Hermeneutica. It's actually a fabulous environment. And Bill Turkel at Western has actually done a whole textbook for digital humanities and Hermeneutica, but it costs, at least Alberta, it costs something like $300 a year for the license. I mentioned IPython, which is free. It's all open source and has all sorts of great libraries. If you're into R, there's a version that's R and so on like that. But we thought, could we actually do something that was even better? Could we build something that was even closer to how a humanist might think? And so here is the first demonstration of of Spiral, which is our little play on the idea of a notebook and spiral notebooks and spiraling around and so on and so on. Here's a re-implementation of the notebook that we did in IPython, but now done in Spiral, which is a notebook environment that both works with Voyant, but also has all the other features of a notebook environment. You've got text panels here. So these notebook environments, you create these cells that can then interact with each other. You can have graphics. You can then have chunks of code. We're actually working with JavaScript as the underlying language, which is a great language to teach students anyway, because they can also use Node.js or JavaScript for building websites. And then you can call this code. You can actually run the code inside, so that you run that code and it generates this graphic here. And so we are step by step implementing Spiral, so that it can do everything that we think IPython can do and go a step further. And so this is, I'm going to end on showing this Spiral notebook in which we play with ELIZA. So first of all, just to give you a little bit about Spiral, up here are this is the main menu. You can open Spiral notebooks, you can create a new one, you can run all the code in the Spiral notebook, you can export it in some fashion or another, and you can get help. Our help isn't very good. You then have the usual things. You've got the cells of text. You've got controls over here that can move this, so you can delete the cells, you can move them up and down. You have the cells of code. And you see right here, you can run this little bit of code here. And this little bit of code, what it does is it actually calls Voyant and embeds ELIZA with a corpus called Austin. So what we're doing manually, we can now write in code, and on top of it, it gives a starting response back to ELIZA. So I'm going to press that, it ran it, and there you see inside a panel, it ran ELIZA, there's the opening, here's our first message, I love Jane Austen. The script doesn't know anything about the word love. It's psychotherapeutic, so it just sort of gives you a standard thing to elaborate on that. Well, that's not good enough. So this being a nice notebook environment, we can reflect a little bit on it. We can actually call up the whole script if we want to edit it. But we can go a step further. We can actually Right here, we can start to add to the script. Without editing the original one, we can begin to sort of add more rules and see how they're going to work. So down here, I'm going to run here. Here I've got a little bit of code that says, use the original script, add this new bit of script. And now let's see how it responds. So we've added a rule so that it can respond to the word Austen. And it says, oh yeah, isn't Jane Austen a really wonderful author? And I can start playing with this notebook live. It's a little bit twitchy because we haven't sorted all the interface problems out. But I can edit this to my heart's content, and I can play with the script. And I'm unlike the older version of Eliza, where you edit the script and it loses all history. Here, I can be keeping a sort of trace and reflecting back on what I'm doing. And then, and then we go on, and I can begin to edit the parts of the script that actually call the other panels in Voyant. So I've actually written a bit of script that says, show me a concordance. But I could also type it in. So I can begin to now program the way Voyant appears in Eliza inside Spiral. And that's why we call it speed analog. It's sort of going down the drain, if you will, of Spiral and dialogue. And on that note, I'm going to stop and take questions. Thank you very much.
Thank you very much, Geoffrey. It's wonderful. A very theoretical question is, so all the discourse about artificial intelligence is based on the assumption that there is a difference between human and machine, and you seem to propose another model, which is an intelligence which emerges from the merging of and the interactions between human and machine. And the question is there? Can we talk about something? Can we invent another concept in order to talk about intelligence? Just not to oppose, to continue opposing machine and human. I mean, it's difficult to figure out a way to talk about that, but what you are presenting now is just clear to my eyes that speaking about human and machine is not.
It's not that important.
It's not that important, and it's not a meaning anymore, because there's not a tool and a human. There is something going on in interaction between different forces, perhaps, but there is not a human and a machine. This frontal model doesn't work anymore, and so perhaps all the dream about artificial intelligence and the fears about artificial intelligence are not well based, because there's no artificial and natural. That there is an interaction between different forces, algorithms, scripts, first, I don't know, and so on. And there is no a human, and I don't know what you think about that. And if
I think for Weizenbaum and Hofstadter, they very much were trying to figure out how to make machines that understood the world. So when they used a word, they had maybe not the context, the embodied context. This was Dreyfus's point, coming from Merleau-Ponty and so on, that it's not enough just to have a set of rules about what words mean and then apply them logically. There's embodiment to our knowledge. Nonetheless, what really irked Weizenbaum and then Hofstadter was that people thought the computer understood in some fashion when it wasn't. And that was also part of the problem, is that the moment you went outside the rules or played with the rules, you got ridiculous answers. Whereas any system that understood would fail more gracefully. I think you're right that AI has moved on. I mean, that was a first generation of AI in the 70s, early 80s that was actually trying to maybe pass Turing tests. I think now AI has moved on, and especially the AI that you see in games, exemplifies this idea of expressive processing that we're through, where it doesn't really matter if the AI understands. What matters is that it's playful and degrades gracefully, and you can suspend your disbelief and actually think that you're running around in a jungle on some planet shooting aliens. And we do. And the AIs in games have gotten actually quite good at that, partly by limiting what we're doing. My reflection is sort of, I think, going back to something almost too obvious to state in the humanities, that we have always part of our thinking has been dialogical in the sense of reflecting on that, expressing something and then reflecting back on it, whether it was simply writing or talking with someone, then reflecting back on what you get. And there's that form of dialogue. And now what we want to do is to bring the machine in useful ways. And the machine doesn't have to be intelligent. In fact, sometimes we want the machine to be reliable. When you want a concordance, you don't want a toothbrush. You want to say, give me a concordance for this. And most of us, when we interact with computers, we do not want them taking any independent thought. And God knows science fiction has dealt with this problem in great detail.
Is the intelligence on the human side in what you described, or is it in the middle? Because what I understand in your presentation is that actually there is not a human with an intelligence and a machine which helps the intelligence, but it is rather the fact that the intelligence comes out from the interaction between a human and machine. And so the problem of understanding is not a well-posed problem, because there's no intelligence before the interaction. And I would say, okay, the machine is the complex machine, like a computer, is a great example. But when you use, I don't know, a hammer, is quite the same thing. The intelligence is not in the hammer, okay, but it's not in the person neither. It's in the middle. It's in the interaction of the.
Well, I think we could take a sort of, in philosophy, we were talking about distributed cognition. Yeah. And there's recently this can't remember the title. There's a book that has sort of popularized some of these ideas, that in many cases, the knowing, so they're talking more about knowledge, doesn't lie in an individual. We think of a trial. It actually creates actionable knowledge. Somebody is found guilty and put into prison or not. But there's not any one person in that court case that knows everything and made the decision. You have a structure of people and technologies, mostly political or organizational technologies, that structure the knowing and the intelligence in a way. And I think that's what we're doing. When we build these tools, we're trying to use Engelbert's term, we're trying to augment our capacities so that I and the computer and the person who wrote the script and the programmer who wrote the tools, together, we are knowing. And I'm dependent, I'm in a relationship of trust with these other people.
Yeah, I was listening to what you're saying, and I'm glad you just mentioned the term augment, because we know that in the debates about artificial intelligence, the question about sort of real artificial intelligence as something that could work by itself versus some sort of reliance between human brains and processes taking place out of themselves has been a structuring debate from the very beginning. It seems to me what you're dealing with in a very funny way is on the, first of all, the individual is not so individual as an intelligence form. And the second thing is that the tools you're developing are in deep continuity, beautiful, deep continuity in the actual quality in language. It's as soon as human beings or species and animals start developing an ability to communicate some sort of language, then manage to technologically change it by writing, for example, then the whole chain of events begins. And we've been living to that for the last 5,000 years.
And this is why when we first started playing with literate programming, it really appealed to us, because you're both writing out what you're trying to, when you use a literate programming environment, and this actually happens even when I program in other types of environments, you're both describing what you want to be the case. It's like taking notes or something like that, and then you're trying to write code, but the code and the text, and then you get results, and then more code operates on it. It is a writing, but now you have an additional partner. You also have the machine and its capacity to manipulate stuff right in the middle of your thinking through.
But my point is exactly that. The written text is the old machine.
Yes, yes, I agree.
You try to express something in your living kind of environment. You use a code, a language, a grammar, or whatever. You try to do it as best as you can. And you have this machine appearing as a piece of text on some sort of writing surface. And then someone gets it, and then they start receiving that with their own experience and all that, and they start reworking that in the future, and the process keeps on going. What we're doing nowadays is making the intricacies of the communication of people much deeper, much faster, much more intense, and with many more resources. We're essentially building a hypermind. You know?
I think I thought about it quite like I'm reminded of things like chapbooks, the way people used to, part of their writing was quoting other people and bringing and reassembling. And yes, I think there's a content.
I really like the fact that you're going back to the old ELIZA software, because in a way, I mean, you know, we're in an environment now where we have Siri and all these artificial intelligence that help us with our phones and directing us up. So there's part of the question which would be, what is your take on Siri and all those artificial intelligence, and in what way, why did you go back to ELIZA instead of working with some of the protocols already in place right now with artificial intelligence? So well, before asking that question, I just want to go back to the fact that with all your deployment tools you've been building with Stefan, I mean, for me, this is the first time you're really engaging into something which is a dialogue with a reader. Because up to now, we could dump text in deployment tools to the software, and we would get results, and you would have to understand what was the protocol, the coding behind, and sort of understand how the analysis would be done. But now, somehow it's interesting because you went into a more hermeneutical stance with the fact that going towards a dialogue, even if we're starting with ELIZA, but a dialogue between a real reader or an internet user, playing with, behaving in a dialogue or getting into a dialogue with a software that will bring you to another software that will help you understand the text. So for me, there's something really fascinating about that line of programming and working. But back to the Siri and
Siri.
The distinction between the actual AI, which we know right now, and the very first ELIZA program.
So the underlying project, so I was joking before, the underlying project is epistemological. And what we're trying to do is we've been picking what we think are key algorithmic innovations, key algorithms that are important to understanding how we are knowing through computers. And that's why I showed the Mendel law, because it's 1887. It's one of the first attempts to count words, to really do stylistics, and to do visualization. And one of the reasons we're going back to the early ones is that they're so naive. And we believe, and in some ways it's a genetic exploration. If you can look at the genesis, and so we're working our way through a series of them. We've struggled a lot trying to replicate what Father Bouza did. Now, you can read all the stuff, and there's a lot of hand waving, but what was the actual process? He was not using computers. He started off actually using data processing, analog data processing systems from IBM. And we're trying to figure out how did he encode data on punch cards? Because he had, when you look closely, he was the first, he and the IBM engineers, Paul Tasman, really figured out how to use data processing technology on unstructured text. And so it's a series of experiments like that. And when we wanted to do an experiment on the generation of text. And the reason for not doing, Siri would be far too complex, whereas working with Eliza, we could build something that could help people understand some of the, understand the genesis of this. And then, in some ways, it would be another project to try to show how this has evolved into the more sophisticated ones. But it's much harder to decompile or decompose Siri than it is to.
You're going at basically you're starting at the root.
That's where we're trying to start at. So the roots of visualization, roots of, we're going to be giving a congress, we're going to be giving a paper about the roots of content analysis, the general inquirer. We've been going through some of the key sort of early tools and innovations. There's and the method we've been developing, which in some ways is drawn on work with Fruin, is this method of replication. We're not recapitulating. It's not a scientific attempt to do exactly what they did, but we're trying to refold the method in a way that we can understand how people understood it at the time, which is very different from now. Father Bouza was not thinking about tokenization. He was thinking about punch cards, and punch cards in some ways were the program. The punch cards, I could go on for hours on punch cards. So that's the larger project, and okay. Well, thank you very much.
Ok, donc pause café maintenant. Et